Hey, hi guys. Good evening. Good evening and welcome. Good evening. Good evening. Let's continue our discussion on the last mile. I think we were doing a couple of parts on the arithmetic in the last few lectures. I think today is the fourth part. Yeah. Hi guys, good evening. Yeah, we are doing the fourth part today. So we completed about three parts and we are kind of concluding, we are kind of doing the fourth part today. Right, so there I am. So tonight we will do permutation and combination as we discussed previously. So we did couple of arithmetic and then we'll do permutation. We'll mix and match and try to do as many topics or as many concepts as we could in these last couple of days, maybe couple of weeks, 2 weeks to go. All right, so here I am. So I will quickly introduce myself before I start. I'm Belvi Srinivas. I've been working in the test prep industry, especially in the space of CAT, XAT and IIFT in the last 14 years. Yes, I worked in both on the management side as well as on the training side. I trained the students in the space of QA, DI and LR. Yes, and I did develop some good skill in those 14 years to train especially students effectively in this particular space, and also I have good exposure and experience in terms of counseling the students to arrive at their desired goals. That's briefly about me. And how do you reach me? You can use the Telegram channel. This is the channel using which you can reach out to me for short suggestions, or it could be the short discussions. And if you have short counseling needs, this is how you can reach out to me. Yeah, that's pretty much about what my background. I guess tomorrow is a big day, coming Sunday. Sunday is a big day. So Sundays you have to write the mocks, and in case if anybody is having their afternoon slot in CAT, I suggest Unacademy is giving a free mock that is 7th November, so that is 14th November tomorrow. The last one, 14th November tomorrow between 12:30 and 2:30. You can try it out provided your slot falls around this particular time. But if your slots are in the morning or in the evening, I still suggest you better take the mocks in those designated slots as I advised you before. Okay, and if you are looking at some sectional test, you can take the sectional test on these particular days, November 22nd, 24th, 26th. Some sectional tests are being uploaded. If there is a bandwidth and if you can plan it in your preparation, you can take it up, right? Yeah, for any of which you need, and this is the test timing, you cannot take any time that you like. The test needs to be taken between 6:30 kind of. You can try this out. Yeah, good evening everybody. Can I quickly know who are all here? I can see Ashutosh being here, Preet being here, Kishan being here, Vibha being here, Rishabh has joined in, Indrani. I'm good, Indrani. Indrani has joined in. Rajat is here. Okay, great. Thank you, Rajat. Anybody else around here whom I'm missing out? Chandni is here. Srishti is there. All right. Who else? Anybody out here I'm missing out? Just quickly let me know. So it'll be nice to understand who are all into the lecture today. Great. All right, good. Let's get started. We are doing PNC, so we'll keep it crisp and we'll revise maybe 3, 4, 5 kind of concepts and then we will move on. Yeah, hi Rasul. Hello. Yeah. Okay, so sit with your books and pens, and I am hoping that you are all ready to get started. Can you guys quickly acknowledge pen and book are ready? Have you kept your book? Have you kept your pen? Because it's not teaching first, right? It is a reflective action. So I will provoke you with a question. Yeah, provoke in that sense, provoke your mind to think in that sense what I meant. So just a deep thinking. So I will provoke with a question. Most of you should be able to answer it, right? Because we are kind of prepared about 10-15 days to the exam, but given time may not be sufficient. I may end up giving 1 or 2 minutes. You might not like it, some of you. Nevertheless, after that, we will come back and have a discussion. Great. All right. So most of you are right here. Sagar is also joined. Tanuj has joined. Great, guys. Yes. All right. So let's get started. Let me present the first question in front of you. Yeah. Very simple question. Very simple question. Go ahead, friends. Everybody go ahead. Address this. A minute is actually good enough. A minute is actually good enough. Very simple question to start with. This was a CAT question. Answer options were there. I removed it. I think it was coins in CAT. Guys, okay, let me tell you that 6 is the wrong answer. I will give one more minute. Will you guys please revise your answer? I don't know from where you are getting this 6. 6 is the wrong answer. I got it. You are doing a fundamental mistake. 6 is the wrong answer. Can you revise that answer? I'm extending time by a minute. Can you revise it? I'm telling you it is a wrong answer. All right. Okay, I will do the discussion. Okay, so I cannot keep waiting for you to answer the question. I will do this particular discussion. Let me take here, instead of 3 boxes, instead of placing it in the boxes, let me take the names of the people here. Let me take some names of the people. Let's say that I've selected Rishabh. Right, I want to give it to, let's say we'll distribute these marbles to Rishabh and we'll give it to Ashutosh. Okay, we'll give it to Ashutosh, then we will give it to Srishti. Now don't think that why we are not getting the marbles, just like that, right? So I'm just randomly taking 3 names. Okay, so let's say that instead of putting in the boxes, we will give these marbles to them. Both are same. You put in the box or you hand over to the people, all are same. Instead of the boxes, I'm saying that let us give to these 3 people. We'll give these 5 different marbles. And let me give the color also, just in case you're confused why you guys are getting a different answer. Let me call it as red, yellow, blue, green, orange. Let's say these are the 5 colors. There are 5 different marbles. I put a color to them: red, yellow, blue, green, and orange, and I'm trying to give it to 3 different people. So therefore now let's try and see how do I give it so that everybody should get at least 1 marble. Everybody. So nobody should be disappointed. Nobody should be going empty handed, right? So which color they get, I don't know. So first thing I do is what? First I will say that, hey, to one of them, I will make the groups of this. I have to make 3 groups out of this. There are 2 ways to make. I will say that first group is 3. So for one person I decided to give 3. One person I decided to give 1. The other person I decided to give 1. Maybe I'm thinking like this. I'm thinking that, okay, to one person, listen carefully. To one person I give 3. To one person I give 1. To the other person I give 1. That's how I wanted to give. Now who gets 3? That I don't know. Ashutosh may get 3, or it may happen that Rishabh may get 3, or it may happen that Srishti may get 3. That I don't know. That I will do it later when they come and stand in front of me. I will do it. For the time being, I will do 3, 1, 1. Oh, let me decide which 3 should be together. Is it red, yellow, blue should be together? Oh no, is it going to be blue, green, orange together? Let me decide, man, which 3 should be together. How do I decide this? I decide this by 5C3. First, let me decide which are those 3 together, and remaining 1 are as it is. Like I'll just keep them isolated. But I need to decide which 3 should be together. You want red, yellow, blue together, or you want yellow, blue, or green together? I need to decide which 3 should be together. That's what the decision is. 5C3. Okay, groups are ready. Groups are ready means what? So now I am having 5C3 is the groups are ready. 10 ways. I can make the groups ready by 10 ways. This is 10 ways. I made the groups ready. What do you mean by 10? Red, yellow, blue together. Or it can happen that red, blue, and orange were together. Or it is possible that yellow, green, and orange were together. Such configuration is 10 in number. Okay, now I'm standing in front of them. So I have this, let's say dummy. I will take one of them. Red, yellow, blue are together. Then green is one isolated, orange is isolated. It's what is this? Red, yellow, blue. It's a dummy. I know the 10 ways I can do it. One of the ways could be red, yellow, blue are together, orange is one, or blue or green is together. Green is alone. All right. So now how do I distribute this? Now I'll say that Rishabh is standing in front of me. Either I give this to Rishabh, or I give this to Rishabh, or I give this to Rishabh. Assume that Rishabh stood first in the queue. I don't know whether I hand over these three, or I hand over this, or I hand over this, which means Rishabh can be dealt in 3 ways. Rishabh can be dealt in 3 ways. Assume that I gave this to Rishabh. So it is no more. I have to hand over one package to him. I handed over one of them. Though it is 3 ways, I have to hand over something. I handed over. Now Ashutosh is second in the queue. Ashutosh, I can give this, or I can give this. Ashutosh can be dealt in 2 ways. Assume that Ashutosh, I gave this. Okay. Therefore, Srishti is given the remaining one. And hence what you are trying to say, 10 ways of grouping and 3 factorial ways of distributing. Nothing but the same. It is the same story. 5 different marbles keeping in 3 different boxes such that no box is empty is nothing but 3, 1, 1. This is one particular case. Hey, is there a second case? Of course, yes. Why not give 2, 2, 1? Why not give 2, 2, 1? If it is not giving 2, 2, 1, let me do the grouping together. How do I do it? 5, C2. Out of 5 marbles, I kept 2 marbles. Assume that red and yellow are together. I just have to decide which 2 should be together. Fair enough. Now, out of the remaining 3 marbles, I need to decide that another 2 should be together. Probably these 2 are together. Sure enough, that one more left. Keep it as it is. Since 2 groups have the same size, it's a grouping issue. Since 2 groups have the same size, I have to divide by 2 factorial. Right? Whenever the groups have the same size. Now, because you formed 2 groups. See, this 2 and this 2. You formed 2 groups which have the same size. Then you better divide by 2 factorial, or otherwise there will be double counting. Otherwise there is going to be a double counting. And then you say that, hey, this is how much? 10, 6 divided by 2. Therefore 30 ways. You say that, okay, 30 ways I can get this selection done. 2, 2, 1 selection can be done in 30 ways. Very similar. Then you come back here again. Hey, let's say that red and yellow were in one group. I don't know. Some two of them are in group. The other dummy is what? Blue and green are in one particular group, and orange is another one. Fair enough. Now again, so now I say Rishabh, which one I'll give? Either red yellow I give, or blue green I give, or orange I give. Therefore it is again 3 into 2 into 1. And hence you are saying that 30 ways into 3 factorial. Therefore the required answer is 10 times of 30, 10 times of 6, that is 60. Then you have 30 times of 6, which is nothing but 90. Required answer 60 plus 90, which is equal to 150. Okay, I took long time to explain because most of you got this wrong. I don't know how you guys got this wrong. This is the one of the approaches. Takes 1.5 minutes. Trust me, this distribution, etc. Some simple combinations, NCR, some simple combination, and 3 factorial times of permutation. Guys, are you all with me? Clear about this? Clear about this? There is a grouping and distribution. You got to do grouping and distribution. Group the items and then distribute the items. This is one way of approaching. Is this making sense, everybody? If you are confused somewhere, let me know. I hope it made sense. Sorry, this is 15. This is what happens with me on the CAT question, Indrani. Okay, I remember the answers. Okay, now most of the CAT questions I know the answers, so I'll be doing backward integration. It will be in the autopilot mode. If you give me previous year CAT questions, my mind will be in the autopilot mode. I knew the answer and I'll be trying to arrive at that. I knew that 150 is the answer, therefore I adjusted. 60 I got, 90 I wrote. Adjusting the accounting, right? Accounts got adjusted. Technically this is 15, yeah. This is 15. This calculation is 15. This calculation is 15. 10 into 3 divided by 2, 15. 15 into 6, 90. No problem. It was my mistake also. And you guys also went with that number. Logic is clear, everybody? Yeah. Had done once in the group. Okay, Rishabh. Whichever way. It is one of the very powerful and important concepts. Yeah. So, all right, let's go in from here. This should be clear. Now, listen. So, those who want to do, I just thought that I will just touch upon the inclusion exclusion principle. Very simple. I will not get into the proofs part of it. You might have to refer to your 11th standard textbook. You may say, why not proofs, sir? For CAT 12, I will, CAT 22, I will do. But now we don't have the time, right? So if I start proving that, that will take 10-15 minutes for you to explain. And then I have to do some questions as well. Then we will not reach anywhere. By the time I do the proof, you are tired, I am tired. Then we will do some 2 questions and we will wind up. Instead, all right, instead, let me just tell you how the inclusion exclusion principle works. Very, very easy. Just remember, because we use this sometimes in functions also, right? Some function questions also you kind of use. It definitely comes handy. What I'm trying to use, I'm trying to explain principle of inclusion exclusion. Principle, PIE we call it as principle of inclusion exclusion. Some people make pattern. What I did in the earlier case is the pattern. Some people say that, hey, why pattern? Yeah, I know principle. I will apply the principle. Principle gives me the answer because I know the framework. I will put it in the framework. Framework tells me the answer. Fair enough. What is the framework? Framework is this. Framework is total minus at least 1 is empty. At least total minus at least 1 is empty. At least 1 is empty. What is this 1E? At least 1 is empty plus inclusion exclusion. Pay attention to this word. Principle of inclusion exclusion means what? You include means positive sign, exclude means negative sign. Again exclude. Okay, again include what? At least 2 empty. At least 2 empty. Minus exclude what? At least 3 empty. The word use should be at least 3 empty. All this you keep doing it as many times as you want. Finally you get the answer. Fair enough. That is the framework. Principle of inclusion exclusion means when do you use the principle of inclusion exclusion? Whenever they say that at least 1, which means nothing should be empty. At least 1 should be there in each box. Nothing should be empty. All right, now no empty handed. Nobody should return empty handed. No box should be empty. Whenever you have that condition, that is when you can use the principle of inclusion and exclusion. All right, yeah, let me come to this. Hey, what is the total, man? Mindlessly, I don't know whether the boxes are going to be empty or not. My principle will give me the answer. All I think is what? Totally, given some 5 marbles, 5 different marbles, 3 different boxes, total is going to be 3 raised to power 5, period. That's it. Hey, I have box number 1, I have box number 2, I have box number 3, I have marble number 1, marble number 2, marble number 3, 4 and 5. I take my first marble. First marble can be dealt in 3 ways. I can put in the box 1, box 2 or box 3, correct? So all right, wherever I put my first marble, I'll go to the second marble. Even that can be put in 3 ways, any 3 boxes. Therefore 3 raised to power 5. Okay, done. Minus at least 1 box should be empty. Which box? Any box. Either box 1 can be empty or box 2 can be empty, box 3 can be empty. Then why don't you select it which box should be empty? Fine, I will do it 3C1 ways. I selected the box. Let's assume that box 1 is empty. Let's assumption because I have to show, okay, one of the boxes 3C1 means any of the 3 boxes can be empty. I decided that to show you, let me say that box 1 is empty. Fair enough. Box 1 is empty. Now look at the marble. Now go back to the same first marble. First marble can be either placed in the first box or the second box. Okay, 2 ways. First marble can be dealt in 2 ways. Second marble can be dealt in either first box or second box 2 ways. Therefore, you say that 2 raised to power 5, because if one of the boxes is empty, yeah, which means you shut one of the boxes and kept it aside, which simply implies that so remaining 2 boxes you have to fill the marbles in the remaining 2 boxes. 2 raised to power 5 plus 2 boxes should be empty. Decide which 2 boxes should be empty. That can be decided in 3C2 ways, because you may say that, sir, I will keep box 2 and box 3 empty. One of you may say that, no, sir, I will keep box 1 and box 3 empty. Decide which 2 boxes empty. I decided, let me keep these 2 boxes empty. Fair enough. Just a dummy. That's a dummy. But technically it can be done in 3C2 ways. Now look at the marble 1. Marble 1, only 1 box. Marble 2, 1 box. Marble 3, 1 box. 1 raised to power 5 minus all 3 boxes empty. If all 3 boxes are empty, then where you will keep the marbles. So here onwards the pattern doesn't come in the picture, because now you say that at least 3 empty boxes, which means you will write 3C3. If all boxes are empty, then where you will keep the marbles? So therefore that cannot be done. Therefore you say that the pattern has come to an end. This gives me the answer. This should give me the answer. That's what you mean by principle of inclusion exclusion. Write them. What is 3 raised to power 5? 243. This is what 3 into 32. Okay, this is what, this is nothing but 3. So therefore you say that these two numbers added together, 246 minus 3, this nothing but 96, which is equal to 150. This is called principle of inclusion exclusion. Instead of making the patterns, to avoid patterns, whenever nothing should be empty, no box should be empty, or no person should return empty handed, we use the principle of inclusion exclusion. Comfortable? Understood? Understood? I'm not telling the proof. Concept is this. Principle of inclusion exclusion. First you include and then exclude, include, exclude. Keep doing it, keep doing it, keep doing it. And this is the pattern, this is the structure. This is the structure of principle of inclusion exclusion. Very simple. Hey, 11th standard, those who have done 11th standard math and in which you have done permutation combination chapter, this principle comes naturally, right? Without this principle, you cannot, I mean, you may still pass 11th standard. That may be a wrong comment. If you have done PNC, naturally your teacher should have talked about principle of inclusion exclusion. Okay. Okay, nevertheless, I said it and you are all smart enough to understand it. Why don't you give a confirmation that you understood this? Yeah, got it. Simple concept, right? Simple concept. Whether you remember from 11th standard or not doesn't matter. At least now you know what it is. Yeah, cool. Okay. Fine. So here comes another question. Why don't you guys try this? I will give good 2 minutes. I'll give good 2 minutes. Everybody try and answer this question. That gives me some confidence. Go ahead. Repeat question, guys. This is the same question as the previous question. Principle of inclusion exclusion you can use on this, right? Just that number of, there were marbles, here there are balls, right? And it is 6 in number, right? 6 to be placed in what? All right, 6 to be placed in 3 different boxes. Pretty much similar to the previous question. All right, it is different to different because it's different to different and none of the boxes should be empty. Simply use the principle of inclusion exclusion. What do you do first? You will find total. You will find total. Otherwise you have to make the patterns. If you are making the patterns, all right, if there is a making the patterns, this is what you do. Right now you will take this particular 6 and you divide them into 3. You say that, hey, it's going to be 4 1 1. You make the groups and then you distribute. 4 1 1 can be a group. Then you say 3 2 1 can be another group. The fourth wicket 2 2 2 can be another group. Form the groups first, because each group formation also can be done in many ways. Form the groups and then distribute the groups. That is one way. No, I don't want to make 3 cases and form the groups in each case and then distribute it. I don't want to do that. Then use the principle of inclusion exclusion. Total minus 1 empty box, at least 1 empty. at least 1 empty plus at least 2 empty, all right, minus at least 3 empty, but 3 cannot be empty because there are only 3 boxes. If all 3 empty, then we'll not be able to place those marbles anywhere. Therefore this becomes the answer. Just 3 numbers to calculate. The first number total is 3 raised to power 6 because first ball there is a ball 1, ball 2, ball 3, 6 different colors, 6 balls, solid ball. Each ball can be placed in 3 ways. Therefore 3 raised to power 6 minus 1 empty. Which box you want it to be empty? You have 3 boxes. Let's say that one of the boxes, select that box first and then try to put these balls in the remaining 2 boxes, which becomes 2 raised to power 6. Now you said the 2 boxes need to be empty, then select the 2 boxes, 3C2. Therefore only 1 box is left. Naturally all the balls will go into that particular box, which becomes your answer, right? So therefore we know all these particular values. This is 729, right? This is 3 times of 2 raised to power 6, which is 64, right? And then you have another 3 adding back to that, which becomes your answer. Okay, what is the answer? Is that 540? Is that 540? Yeah, right, 540, right. Okay, cool. Okay, so that's a way. This is actually easier. Somebody understanding the principle becomes easier, because if I give a larger number, generally it has not come. Just in case if they give 10 and they say that, hey, put them into some 4 boxes, etc., this becomes a lot easier to do rather than trying to distribute into 4 and making the patterns. It's painful. No, it does not come in CAT. 10 has not come in CAT. It has always been 5 or 6 kind of. Therefore they expect that we can do by patterns. They expect that because patterns is good enough. You don't have to know the principle, but if you know the principle, you can close the question faster. Same thing they expect on the functions as well, right? Sometimes the questions come on the functions, counting the number of functions. You can do it there as well. Fair enough. Let's move further. Next concept. Let's move further. Take a look at this. Then I'm coming to a beautiful question from CAT after this. This warms up. It sets up for the next question. Go ahead. I'll give you 2 minutes. Actually 1 minute is enough. Still I'll give 2 minutes because you guys will be very tired working hard since morning. So do it calmly, do it leisurely, no worries, but do it. All right, guys, let's do this together. Okay, so let me write it for you because somewhere already it looks like you guys are struggling a little bit with this particular question. Let me write them. Say 1, 2, 3, 4. Let me write the numbers for you so that you will understand it rightly. So these are the seat numbers. This is how it is kept in the row. All right, so what do you say? First of all, one fellow should sit here. There is no choice in the matter. Select it because one fellow must sit there. It's given. One fellow must sit there. Okay, we will make somebody sit there and somebody should sit in seat number 8. There are 4 characters called A, B, C, D. So it's given that somebody should be seated in seat number 1, somebody should be seated in seat number 8. Okay, I don't have a choice. I need to select 2 more seats after this. After this, I need to select 2 more seats such that none of them will be sitting adjacent to each other. That's very important. Implies I can't select this, I can't select this, and I can't select this. That much is clear. I can't select these positions. That much is clear. Nobody can sit in seat number 2, seat number 7 and seat number 9. Okay. Now I want to select 2 more seats. If I say that again, just like I was doing before, if I just think, all right, the 2 more seats I need to select. Why? 2 have been already selected. I need 2 more because there are 4 kids called A, B, C, D, right? Yeah. 2 more seats need to be selected. So I can select those 2 more seats in how many chairs are left now? 1, 2, 3, 4, 5, 6, 7, 8, 9. I can select them in 9C2 ways. 9C2 means selection of any 2 out of 9. That's a meaning there, right? Because you have 4 on this particular side and 5 on the other side, 9C2. But the point is, when you do 9C2, you might have selected these 2 as well. As a part of 9C2, these 2 are possible. As a part of 9C2, this is also possible. That's also possible. As a part of 9C2, these 2 are also possible. That is also possible. Yeah, that's a problem. So had I selected these consecutive 2 positions, that is a danger. Remove them. So number of ways of selecting 2 consecutive values. This is 1, 4, 5, second one. This is third one. There are 3 ways. Okay, here 4th way, 5th way, 6th way and 7th way. There are 7 ways of selecting consecutive. That implies that you would have selected 2 more seats which are not consecutive. Simple. That implies that you selected 2 more seats which are not consecutive. I am saying selection. Okay, what is 9C2? 9C2 means I just considered all the available seats. I said that okay, you fellows are available. I did 9C2. But I know that when I did 9C2, some of the seats you selected could have been adjacent as well. Then I went ahead, I just removed the adjacent seats. What are the adjacent seats? 3, 4 can be adjacent, 4, 5 adjacent, 5, 6 adjacent, or 10, 11 adjacent, 11, 12, 12, 13, 13, 14. I know that 7 ways of adjacent selections might have come out of a total of 9C2. What is 9C2? 9C2 is nothing but 36. 36 minus 7. There are 29 ways you could have selected the remaining 2 seats. Say dummy. Okay, you might have selected this particular seat. Say dummy. I'm saying that you might have selected 4 and you might have selected 13. Dummy. Just a dummy. Just to show you that, hey, finally, which are the seats you selected? 1 is selected, 4 is selected, 8 is selected, 13 is selected. How many kids are there? 4 kids are there. Tell these 4 kids that, hey, I've selected these 4 seats. Guys, go and sit. So now these 4 kids go and sit in how many ways? 4 factorial ways. 4 factorial, that is 29 into 4 factorial is the answer. Technically, 29 into 24 is the answer. This is what I am expecting as the answer. Hey, did it make sense to you? Did it make sense? Is this clear? Yeah. 29 to 4. Did you understand this very simple question? Yeah. Think about it. Did we really struggle to solve it? No. Good. Are you guys there? Lost? Yeah. Okay. Is there a lag? Why you are taking time to respond? It's because you are taking time to think before you respond, in the sense, yeah, you want to just take a look and everything is fine, then you will respond. If there is no doubt, if that is causing the delay, it is fine. But if it is a technically causing delay or something, let me know. Good, perfect, very nice, very nice. You are understanding this. This is very nice. So therefore, this is what 24 less than 720, which becomes 696, right? This technically is 696. All right, the calculation is a later part. That's not a worry, but this is what your answer technically turns out to be. All right, okay, here we go. Next one. Let's move on to the next one. Here comes a beautiful question which appeared in CAT, ZAT, IIFT, every single exam. Scenarios change, logic remains same. Get this particular logic. I will give 2 minutes of good reflection time. Try and perform. you would have done somewhere closer to these kind of questions, right? It is not that you wouldn't have done such questions. I don't think so. With the kind of exposure you guys have so far, you would have done somewhere closer to the questions that I'm discussing. Right. Okay. Good. Good. Yeah. So let me quickly come back on this. Okay. So Mumbai, Ahmedabad, you will leave it. What I'm interested in 12 intermediate stations. We have to schedule 3 stops for this particular train. Very good, guys. All right, listen. You have to schedule 3 stops for this particular train, so that no 2 stops are consecutive, right? So that no 2 stops are consecutive. That is what we need to schedule in this particular scenario, right? Okay. So now this is what I have. I1, I have I2, I have I3. That's intermediate station 3, 4, like this, right? I5, I6. This is what I kind of have here. I6, I7. I8, I9, I10, 11 and 12, right? This is what I kind of have. Okay, I can schedule 3 stops. One of the possibilities, listen to the first possibility. I can schedule this. I'm putting a star. It stops here. It stops here. This is the second stop. I have to schedule 3 stops here. That can be my second stop, and this can be my third stop. That is my case 1. So my case 1 can be like this. My case 2 can be like this. Hey, it stopped at station 3, it stopped at station 7, and it stopped at station 12. Possible, right? That is also possible. So let me write my third case. My third case can be like this also. Just an illustration. It stopped here, it stopped in station 12, and in between it stopped at station 3. Possible, right? Possible. Now this is what it means by this. Now this I can use it by using the integral solution. What I say, I will say that, okay, let me start with this particular case. Let me start with the second case. Listen, everybody listen. Let me start with the second case. Number of stations it did not stop before it had its first stop, or 2. There are 2 stations in which it did not stop before its first stop. I'm talking about case 2, my friends. 2 stations it skipped. I1, I2 it skipped, and then it stopped at I3. The number of stations it skipped before its second stop. All right, second stop, or 3. All right, this is nothing but 3. Okay. Number of stations it skipped before its second and third stop. All right, that is nothing but another 1 station, because station 8 it did not stop. The number of station it is going to skip before it reaches Ahmedabad, right? Mumbai to Ahmedabad, before it reaches, it is going to skip 3 more intermediate stations. Now listen to this very, very carefully. Okay, number of stations. Let me come to the third case. Number of stations it has skipped before its first and third stop, 1. Number of stations it skipped before its second stop and its third stop, right? 12 minus 3, which is 9. Okay, let me add something here. Number of stations it skipped before its first stop and the starting point, 0. Number of stations it skipped after its first stop and the last stop and the destination, that is also 0. Now just add up these particular numbers. 2, plus 3 5, this is 6 plus 3 9. What is that trying to suggest? Out of 12 stations, it will skip 9 stations. See, the circles are 9, 2 plus 3 5, 6 and 3 9. Since it is stopping in 3 stations, it won't stop in the remaining 9 stations, that is 9. So look here, is this sum 0 1 9, and this, I think this should be 8. All right, no, this should be 8 here, 8 stations. In between there should be 8 stations, right? There are 8 stations. 8 plus 1 also is becoming 9. Okay, what I'm trying to suggest, put a definition like this. There are, all right, first station, first stop number 1, and there is going to be a stop number 2, there is going to be a stop number 3, and then there may be some stations. Now here is Mumbai, here is going to be Ahmedabad. Now it is possible that it stopped at X, it did not stop at X1 stations. It did not stop at X1 stations between Mumbai and its first stop. It is possible that it did not stop at X2 stations between the first stop and the second stop. It did not stop at X3 stations between its second and third stop, and it did not stop at X4 stations between its third stop and Ahmedabad. All right. What is the value of X1 plus X2 plus X3 plus X4? The value of this is 9. Why this is 9? Because since it's stopping at 3 places, not stopping has to be the remaining 9 stations out of these 12 stations, out of which X1 can be 0. The value of X1 can be 0. The value of X2 should be 1. What is the definition of X2? Number of stops between the first stop and the second stop. Number of stations between the first stop and the second stop. Minimum 1 it should be. It should be minimum 1. Can this be 0? X1 can be 0. Yeah, because it can stop at the very first intermediate station after Mumbai. Possible. Okay. So now similarly, X3 should be greater than or equal to 1. Why? Number of stations between second stop and the third stop should be minimum 1, because it cannot be consecutive. But number of stations between the last stop and Ahmedabad, can that be 0? Yeah, that can be 0. That can be 0. And hence you are saying that, hey, I just have to find the integral solutions for this particular equation. So how do you find it? Give 1 here. All right, wherever the 1 has to begin, you give 1, and hence you say that X1, X2, X3 and X4 is also equal to 7, and you know that each equation has come down to the 0 stage, and hence you say that answer is going to be 10C3. Your answer is going to be 10C3, that is 10 into 9 into 8 divided by 3 into 2. This is 4 times and 3 times, which is nothing but 120. Conceptually, this is about this particular question. Okay, explanation does take time, and given this is not the approach, I gave the approach to you so that you first understand how this can be technically worked out. Okay, is this clear? Is this clear? Is this clear? Yeah. These two are entirely different questions, Karan. These two are entirely different questions. Don't mix that question with this particular question. Right, because it is the same train which is stopping, and the other side there are 4 different people who are trying to sit. Yeah, they're entirely different things. This is a train, it's the same train going. There are not 4 different trains going, right? Okay, now listen, everybody listen. What you kind of do is, hey, once you understood this, okay, this is one approach. Those who did not get this particular approach, let's try and use it by the gap method. All right, now so there is another way, all right, quicker way to think about this particular question. In fact, I wanted you to understand that, but nevertheless, this is the crux of the matter. All right, this is the crux of the matter, what we did on this particular question. All right, so now let me come to the smarter way to understand this. Okay, you have these 1 2 3 4 9 stations. All right, 9 stations versus 3 stations. Divide this 12 into 9 versus 3. 9 stations, it does not stop. Remaining 3 stations, it stopped. Forget this. All right, now we'll squeeze in later. What we'll do is we'll squeeze these particular stations. In the sense, now we are trying to form a map. You simply put these 9 stations in a row. Simply put these 9. See, you're just playing. Assume that you are playing with the toys. Don't fix that geographically. Oh, Ahmedabad is here, Mumbai is here. How you can play like that? Hey, just assume that you are playing. Ahmedabad is one place, Mumbai Mumbai is another place. You are playing with the toys. I'm saying that, hey, just simply put 9 stations. You give the names later. Yeah, so whatever the names of these particular stations, simply put 9 stations, call them as stations. Assume that you have some building blocks. Put those 9 building blocks and call it as a station. How many ways you can arrange these 9 stations? One way. Just arrange them one way. That's it. One way you arrange them, because they're all building blocks. Nine stations you arrange, which means you put a building block here. You call this as a station. Another building block. Another building block. 3, 4, 5, 6, 7, 8 and 9. Okay, you kept 9 building blocks. All are same, doesn't matter, it's the name of the place, it's in the order. You simply put 9 building blocks and said that these are the 9 places. Okay, now what you do is these 3 places you squeeze so that already in the same gap you don't squeeze 2 stations. What do you do? Identify a gap. Hey, I can squeeze. Another 3 building blocks are there. These 3 building blocks should be separated by these 9 building blocks. Very simple. These 3 building blocks cannot be together. What about these 3 building blocks? A different color. Assume that these are yellow color building blocks. Yellow color building blocks means the train will not stop. Okay, now let me come to these 3 building blocks which are green in color. Where all I can write this green building blocks? You can put it here. You can put it here. Second gap, third gap, fourth gap, fifth gap, sixth gap, seventh gap, eighth gap, ninth gap and 10th gap. Where you want to put it wherever you want. Let's assume that, okay, you decided to use this particular gap, and you decided to use this particular gap, and you decided to use this particular gap. You may say that, no sir, I will use 3 consecutive gaps. Please use it. Please use it. Use the 3 consecutive gaps if you want. Doesn't matter to me. Alright, which ones you use. So therefore, what you are trying to say, there are 10 gaps. There are 10 gaps. I need 3 gaps for my blue building box. Therefore, you say that my answer is going to be 10C3. Out of 10 gaps, I need to select 3 gaps, and this is my answer. Precisely with whatever you tried to do. What you are trying to do, you took 9 building blocks and you gave them the yellow color. You said that in the yellow building block, the train will not stop. And you took another 3 building blocks and you gave them the blue color, and you said that this is where train is going to stop. But wherever the train is going to stop, that should not be consecutive. The blue building block should not be consecutive. Therefore, what you do, first simply arrange the yellow building blocks and then identify the gaps. In the gaps, try to squeeze 3 building blocks. That's it. Alright, there you identify 10 gaps. Put any 3 building blocks of the blue color into that particular gap. Are you with me, guys? Clear on this? This is the easier way to understand. The building block is just a concept. Building block is just a concept. Assume that you are playing. Don't fix the geography. Mumbai, Delhi. You may say that how can you move the places like that on the geography? I'm not moving. Take it as a game just to understand. It's the same concept there. It's the same concept there. I hope it's making sense, everybody. Making sense? Yeah. No, I didn't explain this before, because if someone don't understand this, at least that they should understand. Between the 2 methods, at least one you should understand. Yeah. At least one you should understand. Which way you understand doesn't matter. Right? These are the 2 possible explanations for this. Because suddenly if I say building blocks, you may think that how you are moving the geography like that. Right? Yeah. We can do that. It's a game. All right. Why it can't be 12C3 minus 11? Rasul, if you understood this, stop with this. Don't worry. It is not 12C3, because the first stop can be the intermediate stop. X1 value can be 0. Right? X1 value can be 0. Okay. What is example 13 and 14? Subtracted the cases where the intermediate stations might come. In example 30, I didn't understand, Varun. There are only 12 intermediate stations. Where is 13th and 14th coming here? Where is the question of 13th and 14th when there are only 12 intermediate stations here? And you have to schedule the stop in only these 12 intermediate stations, because train is anyway going from Mumbai to Ahmedabad. You don't have a control. The train has to stop at Mumbai and Ahmedabad. Right? I3 and I4. What happened I3 and I4? Why not 3 there? Then again you have to, Rasul, in that case you have to take 3. How do you know that exactly 2 will be together and the third is separated? I understood. Okay, that's how you are coming. Okay, because the thought is much beyond that. Both Rasul and Varun, thought is much beyond that. You are thinking that in I3 and I4 only you will be there. Why not I5? Why not I5? How do you know that your third station is going to be separate from these 2? That case also may be possible. Why only 2 will be adjacent? I am saying that all 3 were adjacent. Who will subtract these cases now? Both Rasul and Varun. Did it make sense what I am talking? You are saying that exactly 2 will be together and the 1 will be separated from them. I am saying that all 3 can be together. Then who will consider these cases? It's a mess. Exactly 2 together, exactly 3 together. Now doing exactly 2 together is a mess. Are you with me? Is this making sense? When you say exactly 2 together, when you subtracted 11, you are saying that exactly 2 is together and I know that third will not be together in the 12C3. I am saying that in 12C3, this case is also possible, boy. This case is also possible in 12C3. When you selected 12C3 and then you are subtracting 11, first of all in 12C3, this is a possible case. Who will subtract this case now? Yeah? Okay. Good. Anyway, let's move on. Okay, I clarified your doubt. Why 12C3 minus 11 is not the answer? I clarified it. Because when you do 12C3, this is also a possible case, which you are not considering and hence it will not make sense. Okay. Yeah, cool. Let's move on. Let's move on. Let's move on. Let's move on. Yeah, let's move on. Okay, let me directly open to a cat question. Let's directly open to a cat question. Okay, answer this. Go ahead. I thought I will do a warm-up question, but I'm directly doing a cat question. If required, then we'll come back to a warm-up. That was also a cat question. The warm-up was also a cat question. This is also a cat question. Let's go ahead. Okay, now listen, everybody listen. Okay, I will come back and do this question again. We'll go one notch below this particular question. Listen, guys. Okay, stop this, and don't answer. I will come back and we will do that. Meanwhile, 1 minute, why don't you guys answer this question? Simple, elegant cat question, word to word as it is. Word to word as it is. At least in the previous question, I changed it a little bit. This is word to word as it is. Push yourself, and it's a simple and elegant question. I'm sure you guys should have come across. Not exactly this question, this logic, at least popular one. Answer, please. Okay, those who could not calculate whatever the numbers you have written, I'm fine with it, right? Those who could not calculate whatever the numbers you wrote there, I'm good with it. No issues. No issues. All right. Okay, let's take a look. Let's take a look on this particular question. Very good, very good. So what you are trying to do here, pretty simple. You will say that, hey, let all 7 folks sit in 7 factorial ways. 2 ways to answer this. Let all 7 folks sit in 7 factorial ways, but A should come before B should come before C should come before D. In this 7 factorial, these 4 folks would have arranged themselves in 4 factorial ways, because there is when A, B, C, D are also there as a part of these 7 people. Why A should sit before B and B should have sat before C? Nothing like that. Those fellows should have sat simply in 4 factorial ways, but out of 4 factorial means 24. These A, B, C, D could have arranged themselves in 24 ways, but I want only one way. What is that way? I should encounter A first, and then I should encounter B, then C, and then D. Therefore, you say that if 4 factorial should become 1, I should divide this by 4 factorial. That's it. 7 factorial by 4 factorial is the answer. Other way around is what? Hey, there is a first chair, there is a seat number 1, there is a seat number 2, there is a seat number 3, seat number 4, seat number 5, seat number 6, seat number 7. Select 4 seats, select 4 seats. You will first select them in 7C4 ways. Why are you selecting 4 seats? Because these 4 fellows are creating a problem. A is saying that I want to sit before B, C, and D. B is saying that I want to sit before C and D, and C is saying that I want to sit before D. Fair enough. Therefore, you say that select these 4 seats for these 4 problem creators. You will say that, okay, I will select this chair. 7C4 is the total. Dummy, I am showing you. I am saying that S2 I selected, S4 I selected, S6 and S7 I selected. Then you say that, guys, please go and sit. They will go and sit in one way. Hey, why one way? These 4 fellows go and sit in one way. Naturally, A sits here, B sits here, C sits here, D sits here, because that's their preference. That is their preference. They go and sit. Now 3 more characters are left. Let's assume that their names are PQR. Now you say that PQR, man, there are 3 places left. Please go and sit. Those people will come and sit in 3 factorial ways. Either ways is fine. Some people may think like this, I'm okay with it. Some people may think like this, I'm okay with it. Either ways it is fine. Either ways you will get the same number as the answer. Okay, so either ways it's fine. So your answer is technically going to be 7 into 6 into 5, which is nothing but 210. There are 210 ways these fellows can sit. This is one of the very popular and easy level 1 CAT question on this concept. Hey, this is clear. This is clear. Is this clear, everybody? Clear about this? Yeah. Say yes, no, yeah, quickly, yeah. I know you are all tired. Since morning you are working, you are tired. Probably next week we will shift the class to 4 o'clock. Right? Then you cannot complain that I am tired. Of course, you'll be doing a lot of revisions. You guys would be tired. The response of the mind can be a little slower at this point in time. Will that be a good idea? Shall we shift the class to 4 p.m.? Next week, shall we shift it to 4 p.m. in the evening? Would that be a good idea? I don't know. Which means your response would be better. Sometime in the evening is better, or night only is better. If it is evening, write it as E. Write 4 or write 10. Just write that number. What suits you better? Write 4 or 10. Just type 4 or 10. That's enough. So that helps me to quickly understand. Which is your preference? Given these 2 choices, which is better? Rasul, poll and all, now I can't put this. Okay, because I'm working on different systems. By the time I go put the poll, I can just count. Majority I can see, no? Easy observations. 20, yeah, it is not a huge statistics. I'm used to 30,000 lines on the Excel. Right, when I work on the Excel, I will be seeing 30,000 lines and all. What you guys type is nothing. I can easily make sense. That's my point. Because I'm used to thousands of rows and tens of columns in data analysis. So this is not a worry, right? So when you type little bit 20, 30 numbers, it's just not a worry. Honestly, it's not a worry. Okay, because it depends on what we are used to, right? Yeah. Okay, fair enough. I got the idea. Let's go back to the question. I got the idea. Okay, let's go back here. Let's go back to the question. What does it say? All right, now here it's saying that there is a child which is given 3 yellow crayons and 4 blue crayons and 3 identical red crayons. And the question says that all the crayons need to be arranged one beside the other in a row such that all 3 yellow crayons come before any of the blue crayons. Let me put it like this. Okay, let me put it like this. 3 yellow crayons. I said that child, you keep it. 3 yellow crayons. The child has kept it. All right. And the yellow crayons, each of the yellow yellow crayons should come before the blue crayons. Fair enough. So I tell the child that put the 4 blue crayons, the 4 blue crayons are coming here. Are each of the yellow crayons coming before the blue crayons? Of course, yes. Now the point is what? What are the jokers? The jokers are these 3 red crayons. These 3 red crayons are the jokers, right? 3 red crayons are the jokers. Now these are the jokers, 3 identical red crayons. Where all they can come? Where all they can come? Let me identify the gap where all they can come. It can come here, the first gap, second gap, third gap. Let me write the gaps as G1. I can put it here. Gap 2, I can put it here. Gap 3, there is a gap 4, there is a gap 5, there is a gap 6, there is a gap 7, and there is a gap 8. I can see 8 gaps now, right? I can see 8 gaps on this particular premise. Listen carefully. There are 8 gaps. Now I may say that, sir, a child may say that I will select the first 8th, I will select the 7th gap, I will put all 3 red crayons here. I cannot say that. Your wish. I will tell the child that please put it. I don't have a problem with it. I don't have absolutely no problem. 3 identical red. Child said that, can I put all 3 red into this particular gap? Do I have a problem? I don't have a problem. According to this question, it is fine. Child can do that. Now child may say that no, I will keep 2 here and I will keep 1 here. Do I have a problem? I still don't have a problem. I'm still fine with this. So all these are fine, and hence you are trying to do what? Oh, okay, there is a G1, there is a G2, there is a G3, G4, G5, G6, G7 and G8 together should take my 3 sticks. There are 3 red sticks. G1, G2, G3, G4, G5, G6 should take 8, and G1 can take greater than or equal to 0, which means can I write a 0 here? Yeah, alright, now all these can take greater than or equal to 0. That's what you are trying to tell here. Each one of them can be greater than or equal to 0. In the sense, you are trying to say that I will write all 3 red here and all these are going to be 0. I am absolutely fine. You are trying to say that in the gap 6 you are going to squeeze in all 3 reds. I am okay with it. You may say that no, I am going to write 1 here and 1 here and 1 here. In this case it looks like this. Gap 1 has 1, gap 3 has 1 and gap 6 has 1. I am fine with that as well. And then what is that you are trying to say? You are trying to say that number of non-negative integral solutions for this 7 plus 3 10. Answer is 10C3. That's going to be your answer, which is nothing but 10 into 8 into 9 divided by 3 into 2, which is 200 and which is nothing but 120. There are 120 ways the child would have played with this particular sticks. Is this clear, everybody? Is this clear? Did this make sense? All good? Yeah. Clear? Understood? Understood how our favorite concepts keep coming back, because concepts are same, applications keep changing, concepts remain same, only applications keeps changing, right? I hope you understood. I played with the sticks, man. I showed you, man. I showed you. I put the sticks and showed you different colors. That's one good thing I like about these smart tools that we have. Right, actually this is very difficult to show it on the black and white screen, right? In the sense, like in the classroom, 3 different colors will be there, but if you want red will not be there. That's a problem. Yeah, when I'm taking a class with crayons, naturally 3 different crayons I will get. 3 different colored markers I get. Generally I go with 3 different colors, but will there be red, green, yellow? That I doubt. Yellow won't be there. Right, green, yellow, it's rare. One is black for sure, one is blue. Black and blue are common, and the third is generally red. Black, blue, red, you will get those 3 markers. This one advantage to explain. This explanation sits well out here. Good. Shall we go further? Yeah, technology, Rishabh. That's right. Yeah, that's right. All right, fair enough. Let's take a look at this particular question. Read it. You are all pretty familiar with this. Quickly get me the answer. How person can move from A to Z. 2 minutes should be good time, I guess. And I expect answer from everybody. Rasul, there are 8 gaps, 8C3. What is that you are trying to do, man? Why not in 1 gap you can put all 3 sticks? I showed you, no? In 1 gap only you can put all 3 sticks. All 3 crayons you can put in 1 gap. Why you need 3 gaps? Why 8C3? 8C3 is a subset of that answer. Write the superset as the answer. No, why you are writing subset as the answer? 8C3 is the subset of 10C3. 8C3 is the superset. I hope you understood. What you said is also correct, but it's a subset. Okay. All right, guys, listen, everybody listen. Okay, I cannot really scold you guys, right? Had you been in front of me in the classroom, right, yesterday and today's performance, you guys would have had it from me. Honestly, you guys would have had it from me. Right, 15 days to CAT. Only excuse that I could see is 10 o'clock can be a wrong time, 11 o'clock can be a wrong time. Otherwise, I don't expect this. I don't expect means the response I don't expect. I expect a much better response than this. So fair enough. Answer this question any which ways. All of you answer this question. I think at least this you should be able to answer. Answer this. Say that same question. I create a grid like this. I create a grid like this. Yeah, assume that they're all equally spaced. How many ways somebody can go from A to Z if that fellow is allowed to go north and that fellow is allowed to go east? Go ahead, answer this. If that fellow is allowed to go north and that fellow is allowed to go east, only north and east, how many ways he can start at A and reach Z? Answer this quickly, answer this. Right, okay. 10C4, 10C5. Only 2-3 of you know the answer to this. Others don't have no idea about this particular answer. Are you sure, guys? You do something like this: horizontal, second horizontal, third horizontal, fourth horizontal, fifth horizontal, sixth horizontal, right? And then you come back and say that, hey, this is the first vertical, second vertical, third vertical, fourth vertical. So you say that 6 horizontals and 4 verticals. Together I have 10 alphabets. Together I have 10 alphabets, out of which 6 are of one type, 4 are of the other type. Therefore 10 factorial divided by 6 factorial, 4 factorial, which can be written as 10C4 or 10C6. Doesn't matter. Technically this is what you are trying to say. Basically it's a function of n factorial divided by p factorial, q factorial. I have n distinct alphabets, out of which 6 are of one type, 4 are of the other type. This is the concept behind this grid question, right? This is technically the concept. If you ask me what is the concepts, go back to the concepts. From where am I getting this? Concept is this: n factorial by p factorial, q factorial. That is the concept. So you use that particular concept and you close this particular question. Fair enough. So now let me just reduce it a little bit and let me ask you, how did we get to this particular, what if this concept was not known? So for your understanding, let me quickly tell you that, hey, this particular question which came in CAT 1992, I guess, is also a Olympiad question. Which standard Olympiad? Standard 8. All right, standard 8 Olympiad question also. Technically it's a standard 8 Olympiad. question. All right, yeah. So let me tell you that how the standard 8 Olympiad student would do this particular question. Let me illustrate. With the standard 8 NPR, NCR, they will not understand still. All right, they don't understand that still. Okay, so now having understood NPR, NCR, you say that horizontal, 4 horizontal and 3 vertical. You write this as 7C3 or 7C4 because 7 items are there. 3 are of one type, 4 are of the other type. You write this, therefore 7 into 6 into 5 divided by 3 into 2. You say that 35 is the answer. Give the same question to standard 8 student preparing for Math Olympiad. Math Olympiad, this question comes for them. This concept also comes for them. They use the concept of network. They start here. Let's say that A is the point here. They start here. They will say that, hey, what is the minimum number of ways to reach this particular point where I'm highlighting? One way, go straight, man. That's one way. Okay. What is the minimum number of ways of reaching this particular point? Because you are allowed to either go north or you are allowed to go east. Okay. What about this particular point? One way. What about this point? One way. What about this point? One way. From where? From A. From A. A up till here. Let me call this point as B. How many ways you can go from A to B by using either north or east? One way. Go straight. Go straight. Otherwise, there is no hope out here. All right. Next one. How many ways you can reach this point C from A? One way. There is only one way. This is also one way. This is also one way. So there is all these points. These nodes can be reached in one way. Fair enough. Okay. Now let me come to this particular node. How many ways you can reach this or this particular node? You will say that 2 ways. This is 2 way. Which are the 2 ways? I'm highlighting it. This is one way. Like this you come, or you may go the other way around. You may say that no, I will go like this. Okay, 2 ways. Now this 2 is nothing but node values. Hey, from how you approach this is east direction, this is north direction. Add the node values. What is 1 plus 1? You don't have to start from A now because you already generated the matrix. This is 1, this is 1. 1 plus 1 is 2. Hey, how do you reach this? Do you come like this? Hey, what are the node values from where you are coming to these particular places now? Node values. 2 is here because that's where it's coming. Hey, what is the node value from where you are approaching this highlighted point? 1 here. Hey, what is 2 plus 1? This is 3. How many ways you reach it here? There's a previous node value 3 here. This previous node value 1 here. 4 ways. This is how much? 5 ways. Okay, what about this? 2 plus 1, 3. What about this? 3 plus 3. Where is 3 plus 3? Like this. This is 3 here. Like this you come up. There is another 3 here. All right, 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. This is 3 plus 1, 4. 6 plus 4, 10. 10 plus 10, 20. 20 plus 15, 35. They'll say that 35 ways they will come. 8 standard fellow who is preparing for Math Olympiad, he will simply quickly add addition. In 1 minute, he will tell the answer after he draws that particular grid. He will give that answer in 1 minute because they have to do 35 questions in 60 minutes. Therefore, they can't park more than 1 minute for this question, which comes in their Math Olympiad. I'm not saying every time it will come. Once in a while, it will come. Whenever it comes, they will take 1 minute and close this particular question. Maybe 1.5 minutes. They have to just add these particular numbers. Okay, you understood the concept. It's a network concept. Is this clear to you? It's not that you should know this n factorial, p factorial, q factorial. You can add the numbers and you can get the answer. Are you there? This is the concept. This you should know. After this, all the other stuff. Without knowing this, it doesn't make sense. Whatever we write, NPR, NCR, nothing makes sense. Concept of counting is the network. Other than Rishav, Chandani, Ashutosh, what happened to others? Others are thinking that, sir, we did in 8th standard, why you are repeating? Yeah, then you would have done this. If you have done 8th standard properly, then all of you would have given the right answer to my actual question. That's my thing. That's my thing there. Yeah. Okay. Isha, Sagar and Vibar also fine. Okay. Where are others? Chandni is there. Okay. And Chirag, Chinmay, Sristi. Still wondering what is this counting you have done all of a sudden? 8th standard counting we did. All right, let's go on. All right, now come back, my friends. Let's try and see this particular question. Why I'm saying is this is not a CAT question, what I'm writing here. CAT question was based on this. It was little better than this. It was in fact little better than this. Nevertheless, let's come back and attack this particular question. You are at A. How many ways you reach this particular point? 1 way. How many ways you reach this particular point? 1 way. Why? Because you are simply supposed to go straight. You are supposed to go straight. Okay. How many ways you reach this particular point? 1 way, 1 way. This is 1 way. This is 1 way. This is also 1 way. Why? assume that this particular point is called B. You want to go from A to B, go straight, man, because you are allowed to go either go north or east, one way each. How many ways you go here? This value is 1, this value is 1, therefore 1 plus 1 is 2. Why? Eastward and northward. Put those arrows and check the previous numbers. Eastward and northward, 1 plus 1 is 2. Very good. All right. Hey, what about this? 1 here and 2 here, therefore it is 3. Okay. What about this? This point is called as B. How many ways do you reach a point called B? Simple. Hey, there is only one arrow here. You may say that, sir, where is the arrow here? It is not there means not there, man. There is only one input value. What is the value of that particular node? 3. Therefore, this place can be reached in 3 ways. Okay, everybody confirm that B can be reached in 3 ways. Is that clear? Why I wrote 3 in place of B? B is a dummy value. This node is called as B. Why I wrote 3 in place of B is clear? Because there is only one input node. East is the only way to reach B. Is that clear? Everybody? Is that clear? Because once that is clear, everything is clear. Right? Good. Very good. Very good. You guys are smart. That is something I like about you. Yeah, I tell once and you kind of catch it. That's very good. Yeah, fair enough. Fair enough. Let's go on. Let's go on. Okay. So now this is 2 plus 1, 3. This is 3 plus 3, 6. This is 6 plus 3, 9. Okay. Still here it is 9. If I call this point as C, there is only one input in here. Okay. Firstly, why did we call this point as 9? Why this is 9? You can come from here in 3 ways. You can come from here in 6 ways. Therefore, you said that 6 plus 3, this fellow will become 9 ways. Fair enough. And coming to the next one, this also would become 9 ways. If I call this point as C, this can also be traveled in 9 ways for a simple reason that there is only one inputting for this. That's going to be 9 ways. Coming to this is 4. Let me quickly write that 5 and let me quickly write that is 6. Hey, what about this particular place? Only one way, 9, because you can't come through water, right? There is another one there. Hey, I will come from here. I will keep swimming. No swimming and all, right? So you can't come like this. It's blocked. All right, water is there, and hence there is only one input for this. This is the only input, and hence you say that this can be done in 9 ways. Fair enough. Hey, what about this? 9 plus 9. This is going to be 18 ways. All right, good. Hey, what about this? There is only one inputting. Let me call this point as K. Let me call this point as K. You can't come through water. All right, no swimming allowed. So therefore you come through only this particular point, and hence you say that this is 5. Hey, what about this? 9 plus 5, 14. What about this? 14 plus 8. All right, 14 plus 18. All right, which is nothing but 32. Which is nothing but 32. What about this particular place? 32. Coming to this, 5 plus 6, this is 11. This is 14 plus here, 14, and this is 11. Therefore, this is 25. 25 plus 32, which is going to be 57. Finally, 57 plus 32, which is going to be 89. There are 89 ways of dealing with this particular stuff. This is the only way to do this problem. This is the only way. Addition. Look at the diagram quickly. Add the numbers. It will take 1 minute to add the numbers. Maybe 1 minute for you to copy the diagram, because this diagram might come on the screen. You can't literally write on the screen of the computer. Probably you want to copy it, or there itself you keep counting it. If it is confusing, naturally you will draw this. Maybe to draw you may take a minute, to solve you will take another minute. Fair enough, my friends. Everybody is clear on the concept? Everybody is clear how we calculated this? This counting is important. Your n factorial by p factorial q factorial will not come. That stopped coming in the exam. That is 1992 question. 1992. We are in 2000, or we are in 2020, right? 28 years back. It won't come now. This is what the concept they test now. This is what they test. And you forget the network itself, then it is not going to help us. It will not take us anywhere. Okay, cool. That's nice. Very good. Very good. Try this question now. All of you, apply the logic. Try this particular question. Yeah. Okay. Calculation might take some time. If you have got the logic, sure. All right. You have to add up some 3-4 numbers here. Therefore, that might take some time. But nevertheless, let's understand this. Let's do this. Let's do this. Listen, my friends. Everybody listen. Be with me and listen to this. One. Okay. If I decided not to go northeast, then all I got to do is what? Horizontal. So all I got to do is this. Okay. One horizontal, second horizontal, third horizontal, fourth horizontal, fifth horizontal, then first vertical, second vertical, third vertical, fourth vertical. You are trying to say that I may have to do 5 horizontals. I may have to do 5 horizontals and I may have to do 4 verticals, right? That is how many ways you can deal with this. 9 factorial divided by 5 factorial, 4 factorial, which is also nothing but 9C4 or 9C5. Assuming, what is the assumption you made? Damn, I don't use the diagonal lines. Okay, you don't use the diagonal lines. Now the point is, you decided to use one. This is what? Case 1. Case 1 is what? No diagonal line. Okay, no diagonal line, 9C4 ways. You may say that no, I use one diagonal line. You decided to use one diagonal root, one place, one unit of diagonal line. If you want to use one unit of diagonal line, then one horizontal and one vertical will go away. So you will have to do just 4 horizontals. And one horizontal and one vertical is now substituted by one diagonal, and you will end up doing remaining 3 verticals. What I meant by this, hey, I will do 4 horizontal. Follow my chalk here. 4 horizontal might look like this: first horizontal, second horizontal, third horizontal, fourth horizontal. Okay, after 4 horizontal, you said that one diagonal. One diagonal means you reached this place, and then you are saying that 3 vertical, 1 vertical, 2 vertical, 3 vertical, you reached it. So whenever one diagonal comes in the picture, one horizontal and one vertical goes away. All right, instead of doing one horizontal and one vertical, you will do one diagonal. That's the meaning of doing one particular diagonal. Fair enough, we kind of understood. But the point is what? Hey, this can be done in, now how many variables? 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial divided by these 4 are of one type, therefore 4 factorial. These 3 are of the other type, therefore divide by 3 factorial. You have to calculate. Therefore I said that, hey, there are some 3-4 numbers to calculate here. You have to calculate those numbers. This is what you write there. But the point is, why am I writing 8 factorial by this? My point is, why diagonal should be in between? I can start with diagonal. Then I will do horizontal, vertical, horizontal, vertical, horizontal, vertical, horizontal. Okay. Did I do 4 horizontal? This is 1, 2, 3, 4. Did I do 4? Of course, 1, 2, 3, 4. I did 4 horizontal. Did I do 1 diagonal? Yes, I did 1 diagonal. Did I do 3 verticals? Yes, 1, 2, 3, 3 vertical. This route is also fine. Oh, what is the meaning of this particular route? Let's try and take a look quickly here. First, you did diagonal. You said that I will go here first. Fair enough. Then I go horizontal. Okay, here 1 horizontal. Then you say that I go 1 vertical. Here again you said that I go horizontal. This is done. Again you said that vertical, vertical, horizontal, vertical, horizontal. You said that I will do like this. All right, I will do like this. Fair enough. That is what it means to us. This is what you mean by the answer. You will get another number here. Second one, you say that no, I will use 2 diagonals. Yeah. Why 1 diagonal? I have a provision to use 2 diagonals. Good. If you have a provision to use 2 diagonals, then you are saying that I will cut down 1 more horizontal and vertical from the previous case. And hence you say that I am now left with only 2 horizontals and 2 diagonals. This horizontal and vertical together becomes what? A diagonal for me. Earlier there was already 1 diagonal that I will copy as it is, and I am getting another diagonal. Then I am left with what? 2 more verticals. Alright, 2 more verticals, 3 horizontals. Good. So now 3 horizontal, 2 diagonal, 2 vertical. How many alphabets you can form? So together you have 7 factorial, out of which these 3 are same, these 2 are same, these 2 are same. 3 factorial by 2 factorial by 2 factorial. Calculation does take some time on this particular question. Fair enough. Next one. Similarly, alright, you would have got the idea by now. Fair enough. So you say that, hey, now I will take 3 diagonals, which means 1 more horizontal and vertical is getting to be used, and then 2 horizontals, then you have 3 diagonals and 1 vertical, which is going to be in this case 6 factorial by 2 factorial, 3 factorial. Finally, 4 diagonal, that is the last case. What is the 4 diagonal means to us? This horizontal and vertical becomes another diagonal, therefore horizontal, you are left with 4 diagonals and a vertical, and hence you say that this is going to be 5 factorial by these 4 factorial. 5 factorial by 4 factorial. This vertical is gone. 5 factorial by 4 factorial. Guys, did you understand the concept? Did you understand the concept? Because yes, you should know factorials. I am not denying it, but you should know how smartly to apply, when to apply, when not to apply. That grip I should have. That grip I should have. They bring in all these diagonal lines, all that stuff they will do. Don't go back to 1992 question saying that they will give a grid and they will ask us to calculate. That was for beyond my generation, not even mine, before me, people who did before me, right? For our times have changed. Yeah. By network, it will take a lot of time. Yeah, you can do that. Can I do by network? Yes, you can do, but this is the smarter approach. First number added to the second number, third number, fourth number, fifth number, right? These are the 5 numbers you got to kind of add, so you will get the answer. Okay, good. Okay, guys, are you all learning something, making some sense? I think I revised 4 concepts today. If you go back and look, two questions kind of, I just illustrated about 3 to 4 concepts. About 4 concepts I illustrated. Yep, good. Yeah, more to do with try to understand the line of application. It is not that, okay, we didn't know about them. Each one of them, we knew the concept. Just that, okay, you have to think little smart out there so that you understand the underlying object, underlying concept. That's right, Risha. What you said is right. What you said is right. That's how you will do. Okay, cool. All right. So that brings us to the end of the lecture. Okay, we have few more questions too, but then fine. We will do it in the next lecture. We'll do it in the next lecture. I will tell you when we'll do the next lecture. Before that, let me quickly put some announcements and then we will finish it. Hey guys, I think today there is some batch launch that has happened. So that's technically for CAT 22. I'm sure most of you, those who are doing with me, is for CAT 21. If anybody is doing for CAT 22, hold on. We will start that CAT 22 very soon. All right, I will just start with the CAT 22. But yeah, so if you are doing CAT 22 and you felt that these concepts are a little deeper, yes, it is deeper from the perspective of CAT 22. And if anybody is looking at ZAT, that is happening in Jan 22. There is a batch which launched, and if you are on the Plus platform, try and take a look. Some of the nice educators have launched this particular batch. All this comes with a subscription. If you want to attend the structured courses, it comes with a subscription, as you know. So subscriptions are for 3 months, etc. 1 month subscriptions are also available, but on all the subscriptions you will get 10% discount when you use any of the educator code. You get 10% discount including my code, which means whatever the listed price that you are seeing on this, you get a 10% discount. Yeah, but if you are looking at it, so if you are seriously preparing for CAT, I will always suggest you to go for the iconic subscription. Benefit being, you will get 25 one-to-one interactions during the course of your journey of 6 months. If it is a 12 months course, you will get 50 one-to-one interactions. So guys, interactions are important with mentors of your choice. Fix up these one-to-one interactions whenever you require, and then discuss about your preparation plan, the study plan, maybe the mock analysis, whatever you want to discuss. It can be interview questions, application form filling. While filling the form, you will have some questions. All that stuff can be kind of taken up. So always take this interactive based things, even if it is online. That interactions does help. I'm telling you out of my experience. All right, good. This is where we come to the end. What we do is, tomorrow all of you write the test, all of you take the mock CAT, write the mock CAT. If you don't write the mock CAT, then don't attend the lecture day after tomorrow, that is Monday, right? Monday don't attend the lecture if you don't write the mock CAT tomorrow, which is Sunday. I'm strictly telling you, don't attend, because it's not going to benefit. 15 days to CAT, and then you don't want to write a mock. Why you want to attend a lecture? You attend for CAT 22 in that case. I mean, I'm on the lighter note, I'm saying it. Unless there is a pressing need, don't miss the mocks. Unless there is a pressing need. If there is such pressing need, so be it. Okay, Monday we will do the lecture, preferably at 4 p.m. all right, or at 10 p.m. or both 4 p.m. and 10 p.m. 4 p.m. we will do algebra, maybe on as a special class. 10 p.m. we will do it on the YT. If I am not doing a special class, then we will do only one lecture at 4 p.m. right? Let's take a decision on that. So I will update it by tomorrow. I will update it by tomorrow. Preferably we will try and do 2 lectures on Monday. 2 lectures on Monday. Are you in for it? 2 lectures is good. 2 lectures is good. 2 lectures on Monday is good. Yeah. So algebra we will do on SC. Whenever we are doing algebra, we will do it on SC. Okay. And on YT, should we do PNC? Continuation of PNC probability? You tell me. Some of you can tell me. At 10 p.m. on YT, whatever we are doing on YT, shall we continue with another lecture on PNC probability? Another lecture on PNC probability, or there is a shift required? Sure, Rishabh. I will put it. You want PDF with notes or without notes, Rishabh? You want that annotated one or non-annotated one? You said that you wanted the PDF. You want with annotation or no annotation? I will try and see if I can create a PDF of this. Yeah, I should be. Then I will put it in the group. I asked a question. Quickly answer, Rishabh. With annotations or without annotations? Whatever. All right. Okay. Fine. Fine. No, you want the question to be clearly visible. Then I will remove those annotations. No. Let whatever the scratch work I have done. So let that also be there along with it. So be it. That's what I meant. You want it to look the deck clean or not clean is the question. That's all I meant. Okay. Yeah. Okay. Fair enough. All right. Okay. Rasul, you were asking how do I get the notes, etc. You can come on this particular channel. So I will put the notes there maybe tomorrow. Now it's kind of little late. So I will put that notes tomorrow. I hope that should help, right? If possible tonight, I will do it. Otherwise, tomorrow I will do it. Tomorrow I will put that notes on the Telegram group. You can pick it from there. This is the Telegram group that you can hop onto. Fair enough. All right. Nice, guys. Nice spending some time with you guys tonight. I will see you on Monday. All the best. Do well on your mocks tomorrow. And sit for the mocks 30 minutes before. All of you, don't start the mock within 5 minutes of sitting there. Sit in front of the test for 20 to 30 minutes before the test. You sit and you kind of visualize and then start, because that's what you will be doing on the test hall as well. So use that additional 20 minutes before the mock. Okay, my best wishes to you. See you guys on Monday. Bye till then. Good night. God bless you. God bless you. God bless you. Good night.